Welcome back. This is the fourth video for Module 2, Lesson 1, in which we are looking at multiplying and factoring polynomial expressions. Okay, we already talked a little about factoring with greatest common factor in a previous video. We also talked about how to multiply two polynomials together, specifically binomials in this case, but you can generalize that strategy for other polynomials too. And we're going to continue looking at multiplying polynomials here in a very specific case that's called a difference of squares. So we're asked to find the product of x plus 2 times x minus 2, and we're going to use the distributive property to distribute the first binomial over the second. Okay, so we're going to multiply. So you can see here they already did the strategy using the table method, so that's one way to do it, just to help organize. You'll notice that they changed the x minus 2 here to be x plus negative 2. That just helps with the organization of your table. So you can still see they drew the line through the plus, drew the line through the plus, and then a line here and a line here, and that helped create these, four cells to fill in. Combining like terms here, you'll see that the 2x and the negative 2x are going to cancel out when you add them together, and so you'll just be left with the x squared and the minus 4. Okay, and you can see here why we call it then a difference of squares, because our result is a perfect square minus another perfect square, right? 4 is just 2 squared. Okay, using the other strategy without the use of the table, and again this is the one they talk about where you have the x plus 2, the x minus 2, and then you just make sure that you multiply this x with that one, this x with the minus 2, and then also the 2 with the x and the 2 with the minus 2 as well. And that gives you all these results right here. And then simplifying yields again the x squared minus 4. Okay, so you'll notice, what do we start with here? X squared minus 4, right? We started with this x plus 2 times x minus 2. And the result here was x squared minus 2 squared, right? That's what these things become. So can you try and figure out then, in reverse, what will t squared minus 25 be? What two things are we going to multiply together here to give us this t squared minus 25, right? If x squared minus 4, a difference of squares, was from x plus 2 times x minus 2, what will t squared minus 25 come from? Well, since we have t's here, right, both of these are going to need a t. Okay, and then additionally, we have this minus 25. Remember, minus 25, though, is minus 5 squared. So we're going to have a plus 5 here and a minus 5 here. And that's how we can factor that. Okay. So now we're working kind of backwards, right? We're not multiplying anymore. We're figuring out what two things, when you multiply them, give you this as an answer. Okay. So let's try this one. Okay. Are these even perfect squares? Right? So again, t squared was a perfect square. It's just t squared up here. 25 was a perfect square. It's just 5 squared. Right? But what about down here? Let's hold off on this one maybe for right now. Is 9 a perfect square? Can you think of two numbers? Or can you think of a number that when you multiply it by itself gives you 9? The answer is 3. What about 4x squared though? Well, 4 is a perfect square. It's 2 squared. And x squared is also a perfect square, it's x. And so there's a perfect square. 2x quantity squared gives you that 4x squared. So then how would this factor? Well, again, it's going to factor into two binomials. All right, it's going to be 2x and the 2x here, and it's going to be a minus 3 and a plus 3. Okay, let's go on to this one right here. Do we have a difference of perfect squares here? Again, yes, 16h squared is 4h squared minus, and then 36k squared is going to be 6k quantity squared. Again, 16 is 4 squared. H squared is just going to be h well squared, right? That's not too surprising. And 36 is 6 squared, and k squared becomes just k quantity squared there. So again, we can factor this, right? It factors. 4h minus 6k, 4h plus 6k. Okay, if you don't believe me, right, you can multiply these back together to see if you get this answer right here. So you could multiply the 4h times the 4h times the 6k, the minus 6k times the 4h, the minus 6k times the 6k, the positive 6k, and you will result in this answer again when you multiply it back out. Okay, last one here. Let's take a look at 4 minus b squared. Why don't you guys try this one? So pause the video, see what you can do about factoring this. Okay, so these are a difference of squares, right? So there's our perfect squares, right? Rewritten as perfect squares. And so this will factor to be then 2 minus b, 2 plus b. You'll notice the order is reversed, right? Normally we had the variable first and then the number, but in this case they're reversed, so we're going to reverse these as well. Put the number first, then the variable. So we 2 minus b, 2 plus b. And that's our answer there. Okay, that's difference of squares. There's 2 more here, so again, why don't you guys try these real quick, and then we'll do the general one right here. Okay, so this one's a little bit trickier because x to the 4th is different than what we're used to, right? But again, x to the 4th is just x squared minus 4, which is 2 squared, and so this will factor to x squared minus 2 and x squared plus 2. Okay, now this doesn't factor any further, unfortunately, because 2 is not a nice perfect square, so we'll have to stop right there and say that's our final answer. All right, for x to the 6 minus 25, we'll do, again, x to the 6 is x cubed squared, and 25 is 5 squared. And so then this will factor to be x cubed minus 5 and x cubed plus 5. Like so. And we'll stop right there as well. So in general then, we're, if we have something in the form a squared minus b squared, so again, a squared is a squared, b squared is b squared, this would factor to be a minus b and a plus b. And that would be your factored form. Okay? Excuse me. I will go ahead and do these 2. So again, if you want to pause the video and try these exercises here, 5 through 7, and then I'll run through these here real quick. All right, so I hope you pause the video, and if not, please do. Please stop, try these problems on your own, see what you can do. All right, so 9y squared is 3y, quantity squared. 100z squared is 10z squared. And so this factors to be 3y minus 10z and 3y plus 10z. And that's as far as we can go there. A to the 4th minus b to the 6th. A to the 4th is a squared squared. B to the 6th is b cubed squared. And so that factors to be a squared minus b to the 3rd and a squared plus b to the 3rd. Okay? And then here, for this next one, it's r to the 4th is r squared squared. And 16x to the 4th is 4s to the 2nd squared. So we'll factor that, and it will become r squared minus 4s squared and r squared plus 4s squared. You notice here they give us a hint. This one will factor twice. So let's look at our answer here. Where does it factor again? Where's another difference of squares? Right here. So this will factor to be r minus 2s and r plus 2s. And then this is not a difference, so we can't factor any. We don't have a sum of squares rule, so this is just our final answer. Okay. Thank you guys, and we'll see you again in the next video.